In mathematics, the Fibonacci numbers, commonly denoted Fn, form a sequence, the Fibonacci sequence, in which each number is the sum of the two preceding ones. The sequence commonly starts from 0 and 1, although some authors omit the initial terms and start the sequence from 1 and 1 or from 1 and 2. Starting from 0 and 1, the next few values in the sequence are 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. Fibonacci, born around 1170 and died around 1240 or 50, also known as Leonardo Bonacci, Leonardo of Pisa, or Leonardo Pisano, was an Italian mathematician from the Republic of Pisa, considered to be the most talented Western mathematician of the Middle Ages. The name he is commonly known, Fibonacci, was used since the 16th century and means the son of Bonacci, Filius Bonacci. Fibonacci popularized the Indo-Arabic numeral system in the Western world, primarily through his composition in 1202 of Liber Abaci, the Book of Calculation. He also introduced Europe to the sequence of Fibonacci numbers, which he used as an example in the same book. Fibonacci numbers are strongly related to the golden ratio. The ratio of two consecutive Fibonacci numbers tends to the golden ratio as n increases. In mathematics, two quantities are in the golden ratio if the ratio is the same as the ratio of their sum to the larger of the two quantities. Expressed algebraically for quantities a and b, with a being larger than b and b being larger than 0, a plus b divided by a equals a divided by b. The Greek letter phi represents the golden ratio. It is an irrational number that is a solution to the quadratic equation x squared minus x minus 1 equals 0, with a value of 1.618033 and so on. The golden ratio is also called the golden mean or golden section. Other names include extreme and mean ratio, medial section, divine proportion, divine section, golden proportion, golden cut, and golden number. Mathematicians since Euclid have studied the properties of the golden ratio, including its appearance in the dimensions of a regular pentagon or in a golden rectangle, which may be cut into a square and the smaller rectangle the same aspect ratio. Some 20th century artists and architects, including Le Corbusier and Salvador Dalí, have proportioned their works to approximate the golden ratio, believing this to be aesthetically pleasing. Le Corbusier's famous modulor is an application of the golden ratio in architecture, aiming to produce an approach to designing living spaces based on the measurements of an average adult male. It has also been used extensively in music, especially for composers to build the macro structure of their works in order to achieve a sense of balance between contrasting parts of the works. The piece we heard at the beginning of this class was Prelude No. 1 by Frédéric Chopin, and it is a piece whose inner proportions are based on the Fibonacci sequence. As we can see, the first major harmonic change takes place at bar number 13, and at that point starts a big crescendo that climaxes at bar 21, and on this moment starts the descent, a big decrescendo that goes up until the end of the piece. Even if we look at the waveform of this interpretation, we can see that the proportions of the building of the tension and of the release of the tension of the music perfectly fit the golden ratio. We're going now to look at one example of Fibonacci numbers being applied to music and serving as a tool for a composer to write his music. We will listen to Karl-Heinz Stockhausen's Klavierstück 9, and we will then talk about how the logic of the Fibonacci sequence governs the music from beginning to end. Karl-Heinz Stockhausen, born in 1928 and died in 2007, was a German composer widely acknowledged as one of the most important composers of the 20th century. He is known for his groundbreaking work in electronic music, for introducing controlled chants, aleatory techniques into serial composition, and for musical specialization. as we said before, a typical Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. But this sequence, by addition of its elements, gives birth to this next sequence: 1, 3, 6, 11, 19, 32, 53, 87, 142. As you can see, we're adding to each number one Fibonacci number. Let's now take a look at the beginning of the piece. The first bar is 142 eighth notes. The second bar is 87 eighth notes, both numbers directly taken from the second sequence we just saw. So the Fibonacci sequence is used by the composer to create the proportions for the first two bars. Let's now take a look at the third bar that, at first sight, does not belong to any of the two mathematical sequences. There are two elements in this bar: the longer notes and the appoggiaturas. Let's take a look at the longer notes and their respective durations. C has a duration of 3 eighth notes. D has a duration of 8 eighth notes. F sharp lasts 5 eighth notes. A lasts 13 eighth notes. A sharp lasts 5 eighth notes. And finally, B lasts 8 eighth notes. All the duration of the long notes are directly taken out of the Fibonacci sequence and put in an almost purely symmetric manner around the central value of 13 eighth notes. The number of appoggiaturas also belong to the Fibonacci sequence, since we can see 1, 3, 2, and 1 appoggiaturas respectively, all of which are Fibonacci numbers. The next section of the work, starting at bar number 4, is a sequence that is made up of 13 bars, all of which have time signatures that are direct references to the Fibonacci sequence. 13 eighths, 2 eighths, 21 eighths, 8 eighths, 1 eighth, 3 eighths, 8 eighths, 1 eighth, 5 eighths, 13 eighths, 2 eighths, 5 eighths, 3 eighths. As we can see, the time signatures are all, with the exception of the 21/8, used both as positive bars, meaning bars where the pianist plays, and as negative bars, where the pianist does not play, so as to have the same number function both as music and as resonance or silence. The next section of the work begins at bar number 17 with a tempo of 60, and it is once again composed of time signatures that all derived from the Fibonacci sequence and lasts 19 measures, a number taken from the second sequence that we saw earlier, with the last one, 4/8, being the only one that does not belong to the Fibonacci sequence. The following bars continue on the same logic, using time signatures directly taken from Fibonacci numbers. This whole section is a gradual elimination of the larger values 21, 13, 8 in a statistical acceleration that moves towards the repetition of the 1/8 bar. Even the tempi present in the piece so far, 160 and 60, are a direct reference to the Fibonacci sequence, since eighth note at 160 and eighth note at 60 are basically quarter note at 80 and quarter note at 30, a multiplication of values 8 and 3 of the Fibonacci sequence, presented as such for convenience reasons, since 30 would have been too slow a tempo for musicians to count. Let's now take a look at page 4. Here, the music has already steadily grown away from time signatures that strictly derive from the Fibonacci sequence, but that does not mean that it has disappeared altogether. Let's pay attention to the tempo changes. Have 3 bars at 60, followed by 1 bar at 160, followed by 5 bars at 60, followed by 1 bar at 160, followed by 5 bars at 60, followed by 1 bar at 160, followed by 3 bars at 60, followed by 1 bar at 160, followed by 2 bars at 60, followed by 1 bar at 160, followed by 1 bar at 60, followed by 1 bar at 160, followed by 1 bar at 60. So here, the Fibonacci numbers are used as proportions for the number of bars played at each specific tempo, regardless of the time signatures, that gradually move away from the Fibonacci numbers. In page 5, the Fibonacci time signatures are once again applied, as is the process of gradual elimination of the larger values. In the last section of the work, the Fibonacci numbers are present both as time signatures, as they have been so far in the piece, but they are also applied as a microstructural level of the music, defining the number of small notes present in each measure. In the beginning, the number of notes and the time signature coincide, but after the 8/8 bar, this is no longer the case necessarily. All the bars have notes that range from 1 to 21, using only numbers on the Fibonacci sequence. Klavierstück 9 by Karlheinz Stockhausen is a perfect example of how a mathematical model, no matter how simple, can function as a foundation for the organization of musical work, both at a macrostructural level, but also for the microstructural. But Fibonacci numbers are not used by composers only for larger proportional structures of the music. They can also be used for rhythm in order to write exponential rallentandi or accelerandi. Here is another example of a Fibonacci rallentando. And another example of a Fibonacci accelerando. You can use the Fibonacci sequence to cover the whole range of the piano with just 9 notes, starting at the top C8 to the low A. As you can see, each melodic interval is a Fibonacci number. Downwards or upward. In the following example, we start at the middle C and we add notes whose distance from the middle C is a Fibonacci sequence. This gives us C sharp, which is 1 semitone from C, D, 2 semitones from C, E flat, 3 semitones from C, F natural, 5 semitones from C, G sharp, 8 semitones from C, C sharp, 13 semitones from C, A, 21 semitones from C, and B flat, 34 semitones from C. In this example, we combine elements from the upward motion on the piano, all notes belonging to this sequence, and we apply a Fibonacci number to the times each chord is played. This creates a sense of accelerando, even if the rhythm is repetitive and stable. In the following example, we build chords whose vertical intervals are Fibonacci numbers, like we did earlier with the horizontal line. And in this example, we build chords where the distance of the highest note from the lowest one is a Fibonacci sequence. You can do this upwards or downwards, of course. And in this example, we combine the chords we built with some Fibonacci rhythms in order to create an accelerando. Now, as an exercise, try to write small musical ideas, not necessarily connected to each other, just autonomous musical ideas that are based on the Fibonacci sequence, or on sequences that you could tie to the Fibonacci one. Think of ways to apply the sequence to pitches, rhythms, time signatures, proportions, tempi, or anything else you can think of. Think of what we saw in the piece of Chopin or Stockhausen and the examples we just saw together. Keep in mind that, as we saw in the work of Stockhausen, the numbers of the Fibonacci sequence do not always need to be in ascending or descending order, but you can also mix them up if you find the musical result more interesting. Feel free to express your creativity, and do not forget that there is no wrong in art.